Hello, scholars. A Deep Thought by Jack Handey goes like this. If you ever teach a yodeling class, probably the hardest thing is to keep the students from just trying to yodel right off. You see, we build to that. A Deep Thought by Jack Handey. And so now we're going to deepen some of your understanding of solving a system of equations by cranking it up and making it, instead of two variables in two equations and solving for an ordered pair, we're going to solve for an ordered triple with equations that have three variables and a system that has three equations. Remember, you will have a worksheet to do after viewing this lesson. So our learning target is really very simple. What we want to do is we want to be able to walk away after watching this video and be able to solve a complicated system of equations, a step up from what we were doing yesterday. Just to describe, a linear system in three variables has x, y's, and z's. It's got coefficients in front of the x, y's, and z's that are non-zero. They can't be zero. They can be negative or positive, but not zero. The solution is going to be an ordered triple that looks like this. It might be something like this, but it's an ordered triple, and that's our solution. That's where we're finding the intersection of these three equations if we were graphing, but now we're going to use the idea of elimination like we did in yesterday's lesson to try to get the ordered triple. So to start at the very end and kind of work backwards, let's say we went through and we eliminated the variables and we found out that x, y, and z are 1, -1, and 3. And what we would do to prove that, or to check it, remember we check all our solutions, is I just plug in the numbers. We want to find out if this, when I plug in the x, y, and z, is equal to 11. Is 4 plus a -2 plus 9 equal to 11? And we say, yep, it is. And we put in x, y, and z in for the second set of variables. 1 minus 2 times -1 plus 3. Is that equal to 6? Well, we say 1 plus 2 plus 3. Yeah, that is 6. That checks off. And then in the last one, 2 times 1 plus -1 plus 2 times 3. Does that equal 7? And we end up with 2 plus a -1 plus 6. 2 plus a -1 is 1, plus 6 is 7. So yeah. So it just shows that you need to check. And when you check an ordered triple in these three equations with three variables, the solution is the one that satisfies them all. By way of strategy, here's what we want to do. We want to kind of label each equation as A, B, and C, and then we're going to try eliminating something in sets of two. We might do A, B, and AC, or we could do A, B, and BC, or we could do BC and AC. Any combination of those three in pairs, what we try to do is eliminate the same variable in each and then solve that system that results from those two like it was a system of linear equations with two variables, and you solve for one variable, like x equals 3, then you put it back in to find out what y is and what z is. That's a long, kind of complicated explanation. I'll show it to you in just a second. But remember, if you end up with an untrue statement, there's no solution. If you end up with this statement that is obviously true, infinitely many solutions. So here's our first example. Let's do it together. Let's call it A, B, and C. What we want to do is look at maybe A and B, because right away I see a negative y here and a plus 4y. I wish this top equation had something x minus 4y plus something z equals something else. And I wish that this was a negative 4y there. Well, I can make it that. By multiplying the top one by 4, I get 8x minus 4y plus 24z equals negative 16. And then I just slide over the other equation, the b equation, and then I add them in the columns. And I end up with 14x. Those y's cancel out, plus 19z equals negative 23. I'm going to hold right here. I'm not going to do anything with that. I'm going to try to find another set of equations with another set of equation with x and z in it to combine with this and solve for one variable. So I'm going to look at BZ or BC. I wish right here I had a negative 4 there. Well, I can make it a negative 4 by multiplying that by 2. So the top equation, 6x plus 4y minus 5z equals negative 7. That's my B equation. My C equation has become this. And when I combine those columns, I end up with negative 2x, the y's cancel out, plus 5z equals 11. What I want to do with that now is bring it over and add it underneath this equation so that I can add the columns and try to get rid of either the x's or the z's. So what I want to do to this right here is I wish it was a negative 14x, so I'm just going to multiply this by 7. And when I do that, I'm going to bring it up over here, multiply it out. I'm distributing the 7 to each term inside in this equation. So negative 14x plus 35z, that equals 77. When I add, the x's cancel out. Here it looks like I end up with 54z equals, when I add here, I end up with 54. And so right away, I see that z equals 1. So I'm on my way. I have a 1 in for my z. I still need to find x and y. So I'm going to go back to one of these equations that I solved for here. I'm going to go back to this one without the 7 because it just complicates it. I could do that and put it in here, but it's harder to multiply. So I take negative 2 times x plus 5 times z, which is 1. That's equal to 11. So negative 2x plus 5 equals 11. I subtract 5 from both sides, end up with negative 2x equals 6. And so when I divide by negative 2, it looks like x equals negative 3. So right away, I can say my x value is negative 3. Finally, what I want to do is take one of my original equations, kind of take the simplest one and use negative 3 and 1 for x and z and plug it in. So I have negative 4 times 3 minus 2y plus 5 times 1. That equals 9. So I end up with a positive 12 minus 2y plus 5 equals 9. I combine like terms, add the 12 and the 5 together. 17 minus 2y equals 9. And when I subtract 17 from both sides, I end up with negative 2y equaling a negative 8. Divide by negative 2, and it looks like y equals 4. So my ordered triple is negative 3, 4, 1. That is the solution that satisfies each of these equations. Another one for you to try on your own. Please pause, do it on your own, and when you hit play again, I will continue. Okay, let's just try this one kind of the same way that we did before. What I notice right away is that if I take A and C, I don't have to do anything to either equation, and a variable is going to drop out. So I'm going to try that. Add 4x. The y's cancel out, plus 3z, that equals 8. That's my first equation. Hold. My second equation, I'm going to try BC because I notice that I have a plus 4y, and if I had a negative 4y right there, that would be beautiful. So I'm going to multiply my C equation by 4. So the two equations are going to look like this. I'm going to have 12x minus 4y plus 8z equals 20. And when I add the columns, I end up with 16x. These cancel out to 0, plus 12z equals 27. Now, I want to hold on this right here. I'm going to put these two equations, this one right here, together with this one. And what I wish is that this equation up here had like either negative 16x or negative 12z. And I think what I'm going to do is I'm just going to multiply this equation. I'm going to get rid of the z's. So I'd like a negative 12z there. So I'm going to multiply by a negative 4. So this equation, then I'm going to bring down here after I multiply it, and I'm going to multiply it and bring it down here and get negative 16x minus 12z equals negative 32. And when I add the columns, those x's cancel, the z's cancel, and I end up with 0. And 27 minus 32 is a negative 5. That is not true, so this is a no solution. What it means is that there isn't going to be any order triple that ever satisfies these three equations at the same time. Here is a cleaned up version of that, showing you that, yep, that's what happens. A little better handwriting. We'll take this one right away. It looks like when I call this A, B, and C, if I take A, B together, those things are going to cancel out really nicely. When I add the columns, I get 2x plus 2y equals 8. And then when I take BC together, those things are going to cancel kind of nicely. And remember, I eliminated the z's. You always want to choose it in a combination where you eliminate the same variable. Don't make the mistake of like getting rid of the x's in one and the z's in another, because it doesn't do you any good at all. So when we add these two together, B and C, the z's cancel out. So we end up with 4x plus 4y equals 16 because this is 0. So what I want to do is I wish this thing up here was a negative 4x. So I'm going to multiply times negative 2, and I'm going to bring that equation down here and get negative 4x minus 4y equals a negative 16. What ends up happening is you end up with 0 equaling 0. What does that mean? It means that it's a true statement. And so the first equation is really the second equation is really the third equation. They're all on top of each other in the same space. So what we say is there are infinitely many solutions. And so we end up showing you there. Okay. The next problem is a word problem, trying to put together some communication skills with mathematical skills, putting the two together. Got this pizza place. You order 3 slices of pizza, you're hungry, 4 breadsticks and 2 cans of soda, you pay $13.35. A second person is a little bit hungrier, has 5 slices, 2 breadsticks and 3 cans of soda. They're throwing out $19.50 for their meal. And then the last statement says that 4 breadsticks and a can of soda cost 30 cents more than just 1 slice of pizza. What we want to do then is figure out how to make a system of equations to solve. So the way that we'll start that is we are going to say that P is the cost of a slice of pizza, B is the cost of the breadstick, and C is the cost of a can of soda. And reading this up here, 3 slices of pizza at whatever cost they are is the first term here in this equation. 4 breadsticks times however much it costs a breadstick is right there, plus 2 cans of soda, so 2 times the value of C is right there. That first order is $13.35. We're going to write a second equation from the second sentence. 5 slices, 2 breadsticks, 3 cans of soda, 5 times the cost, 2 times the cost, 3 times the can of soda cost is $19.50. And I think the toughest equation to write is the last one. It says 4 breadsticks and a can of soda. So 4 times the cost of breadsticks plus 1 can of soda is 30 cents more than a slice of pizza. So we put an equal sign, put 1 slice of pizza plus 30, and those things are supposed to be equal. So what I've done is create 3 equations with 3 variables that I'd like you to solve. What I'll suggest is that you bring this P over here. So really, you're going to have 3 equations that look like this. And then what I would suggest is eliminate maybe the B's. They look like they might be the easiest. You multiply the top equation by -1. You can get rid of the B's and you'll have something P plus something C equals a dollar amount. And then you will, so this is A, this is B, and then I would take B and C together and try to subtract the B's, so you end up with P's and C's. You will work this out on your own and then hit play once again after you pause and work it out on your own, and I will show you what the answer is. I gave you a glimpse of it earlier in that ordered triple. Here it is once you pause and hit play again. There is the solution. $2.95 for a slice, 50 cents a breadstick, $1.25 for a can of soda. Hey, that isn't easy. That's hard work, and they are big problems. What I'd like you to do is your worksheet 3.4. When you are finished, check the answers on Schoology and submit. I have found it best for you to submit PDFs. So scan or take a photo of a page of your worksheet and send it to me. Thanks for listening.